In problem 13, we're classifying these as acute, right, or obtuse based on the side lengths. And so what we'll do here is take the sum of the squares of the two smaller sides, compare them to the longest side squared. So if we take 17 squared plus 18 squared, and we compare that to 25 squared, what we get is 289. And then 18 squared is 324. Okay, the sum of those is 613. And we want to compare that to 25 squared, which is 625. The longest side squared is greater, therefore you're looking at an obtuse triangle. The next set of values, we have a 3x, 4x, and 5x. That is a common triple. So right away you should recognize that this is a right triangle. If I want to confirm this, I get 3x squared plus 4x squared and compare that to 5x squared. So this gives me 9x squared plus 16x squared, or 25x squared compared to 25x squared. They are equal, so it confirms that I have a right triangle. Okay, in the next problem, I take the sum of the squares of my two shorter sides. So 36 squared plus 47 squared. Compare it to the square of the longest side. And so when I calculate these, I get 1296. 47 squared is 2209, and I'm comparing that to 59 squared, which is 3481. When I combine these two measures, I get 3505. Since the sum of the legs squared is greater, I'm dealing with an acute triangle. The final example here. First I need to figure out which of these is the smallest, or which of these is the largest side. So if I think of each of these, or if I think of the value of 4 root 13, it is approximately 14.42, so that is my longest side. So I'm going to take the sum of the squares of the two smaller sides, and I'm going to compare that to the longest side squared. So when I do that, I get 64 and 144. When I combine those together, that gives me 208. And here when I square the 4, I get 16. Square the root 13, I get 13. And 16 times 13 is 208. Since these are equal, my final set of numbers will give me a right triangle.